Alright guys, so this is the second video for lesson 7.2 and 7.3, and we've already covered in the previous video all of the notes, as well as we went through all of these. Let me make this a little bit smaller. So all of this factoring quadratics review. Alright, we went through all the major methods to factor quadratic equations, or quadratic expressions, I should say. All of the practice problems are going to be utilizing these methods to solve these quadratic equations. All right, so what I'm going to do here is I'm just going to kind of fly through these and apply whatever method is necessary. And by the way, multiple methods could work for many of these. Okay. Anyway, let's go ahead. So this first one here, I've got a trinomial, and a is not 1, so I know I'm going to have to do the x method, and I'm going to have to go all the way through the x method. So 2x squared times 5, first term times the last term would be 10x squared, and this is going to be multiplication, and negative 11x. This is going to be addition. And what two numbers multiply to get to 10x squared and add to get to negative 11x, and that would be simply negative 1x and negative 10x. Okay, so that's what this guy is going to break down to. So we will say 2x squared, and instead of negative 11x, it's going to be negative 1x minus 10x, and then plus 5 is equal to 0. All right, I'm going to factor by grouping in this case. So I'm going to pull out of the first two. I'm going to pull out an x, and that leaves me with 2x minus 1. The next two, I'm going to pull out a negative 5, and that leaves me again with 2x minus 1 is equal to 0. I have a greatest common factor of 2x minus 1, so I'm going to pull that out front, 2x minus 1. And I'm left with, on the inside, x minus 5 is equal to 0. Now I have two things multiplied by each other equal to 0, set them both equal to 0. So 2x minus 1 is equal to 0, and x minus 5 is equal to 0. So that means that when I solve for x, x is equal to 1/2, and x is equal to 5. There you go. Next one. This one, a is 1, so I can use the x method, but I can cheat. So in this case, multiplication, addition, I need two numbers that multiply to 15. Oh, I'm sorry. Hang on a second here. They threw this 15 on the other side, didn't they? So this becomes x squared plus 2x. Need to bring that over to the other side. So minus 15 is equal to 0. Should always start with these equaling 0. All right, and so anyway, this should be negative 15, and we have a 2 on the inside. So what two numbers multiply to negative 15, add to 2? That should be positive 5 and negative 3. And so because a is 1 in this case, I can go straight to my answer, or to my factors, which is x plus 5 and x minus 3 is equal to 0. And now I'm going to separate both of these. So here I have x plus 5 is equal to 0, and x minus 3 is equal to 0. And so x is equal to negative 5, and x is equal to 3. There you go. All right, C. Another x method here. This one, 3 is not, the coefficient is not 1, so I have to do the full x method. So 3x squared minus 4 will be negative 12x squared. That's my multiplication, and I just have 1x here, and that's my addition. So two numbers that multiply, that should be, looks like positive 4x and negative 3x. All right, and so let's go ahead and break this up into 4 terms. So 3x squared plus 4x minus 3x minus 4 is equal to 0. That looks like a 6. That's a 0. Factor by grouping here, I'm going to pull out an x, which is left with 3x plus 4. And pull out a negative 1. That's all I can do. If you can pull out that negative, pull it out, and it's going to be negative 1. Changing that to 3x plus 4 as well is equal to 0. Pull out your GCF of 3x plus 4. and you're left with x minus 1 on the inside, which means that x is equal to negative 4/3 when you set this equal to 0, and x is equal to positive 1 when you set that equal to 0. And that does not look like a 4/3, does it? That is worse. This autocorrect. Okay, that is still pretty bad, but at least you can see what it is. All right, next up here, let's go ahead. We got another trinomial, and we've got a coefficient of 6, so we got to do the whole thing again. So negative 30x squared for multiplication, negative 13x. And so it looks like that, initially I was thinking 3 times 30 because of the 13, but you can't add, it has to be a negative 30, so it has to be negative 10 and positive 3 or vice versa, and that won't get you to negative 13. So we're looking at negative 15. Hang on a second. Negative 15x, and then times 2. So positive 2x. All right. So let's go ahead and do this. So I have 6x squared minus 15x plus 2x minus 5 is equal to 0. Go ahead and factor by grouping. So I am pulling out a 3x here. So I'm left with 2x minus 5. And I'm pulling out, I can't pull out anything here, so I'm going to pull out a 1. So plus 1 times 2x minus 5. It's a good problem there. All right, a lot of students might slip up on that. All right, so now I have 2x minus 5 for my greatest common factor. We'll pull that out front. 2x minus 5, and then times 3x plus 1 is equal to 0. And setting both of them equal to 0 means, and then solving, you have x is equal to 5 halves, and x is equal to negative 1/3. Okay. All right, next up here. Let me save this while I'm working. All right, another problem with a is not equal to 1, so we're going to go through the whole thing again. Negative 24x squared and negative 5x. All right. And two numbers that multiply, let's see, what can that be? 8 and 3 it looks like. So I've got negative 8x and then positive 3x. So split it up here, 2x squared minus 8x plus 3x minus 12 is equal to 0. All right, factor by grouping, I'm going to pull out a 2x, and that leaves me with x minus 4. Pull out a 3. That leaves me with x minus 4 is equal to 0. And so I'm going to pull out my x minus 4. Oops, x minus 4 is my GCF. And that leaves me with 2x plus 3 on the inside is equal to 0. Setting them both equal to 0 means x is equal to 4 and x is equal to negative 3 halves. All right, next up here. Same type of problem. They're just throwing this 2 on the other side. We have to put it in standard form. So 3x squared plus 7x plus 2 is equal to 0. We'll use our x method. So that would be 6x squared and 7x. And here we have multiplication and addition. And so that is going to be 6x and 1x. And let's go ahead and split this up then. So that's 3x squared plus 6x plus 1x plus 2 is equal to 0. Factor by grouping, pull out a 3x, and that leaves me with x plus 2. Pull out a 1, that leaves me with x plus 2 is equal to 0. Pull out your GCF of x plus 2, and you're left with 3x plus 1 is equal to 0, which means that x is equal to negative 2, and it is equal to negative 1/3. There you go. Another way of writing what x is equal to. All right, next up here, in this case, there's a couple different ways to do this. You can either just solve for x by adding the 12 over and then divide by 27, taking the square root. Or you could pull out a GCF, which makes it easier. So in this case, I can pull out a 3, it looks like. If I pull out a 3, that leaves me with 9x squared minus 4 is equal to 0. And this happens to be a perfect a difference of squares. So let me bring this up here. So this is the same thing as 3 times, let me make this bigger so you guys can really see what this is. 3x squared minus 2 squared. That's what makes it a difference of squares. Equals 0. So anyway, when I break this up, it is simply 3 times 3x minus 2 times 3x plus 2 equals 0. I have 3 things equal to 0, and by the way, you could divide this by 3, which is what you should do, because 3 cannot equal 0. You could say, oh yeah, I've got 3 solutions, 3 is equal to 0. Well, that's not true, right? So it's not a solution. You could do it that way, or I would prefer you just say, okay, I'm going to divide that 3 out, and 0 divided by 3 is 0. So we have 3x minus 2 times 3x plus 2 is equal to 0, which means that x is equal to plus or minus 2/3 when you solve. Set them both equal to 0. All right, and then last one here. Not a lot of room to work with, is there? So they've got the 5x. They're just putting things out of order for us. So putting it back in order, I'm going to subtract the 5x to this side. That's a minus 4 is equal to 0. Let's do the x method. In this case, it's negative 24x squared, and that's the multiplication, and negative 5x is the addition. No room left to work here, is there? Let's see. So it looks like it's going to be 8 and 3. So negative 8x plus 3x. So let's split this thing up here. Let me move over here because there's just no room. So this is 6x squared minus 8x plus 3x minus 4. And I'm going based off of this, by the way. That's our standard form of this. So anyway, so factor by grouping here, I'm going to pull out a 2x. That leaves me with 3x minus 4. And I'm going to pull out a 1. 3x minus 4 is equal to 0. Pull out your GCF of 3x minus 4. 3x minus 4. Really running out of room. Let's see if we can fit this in. 2x plus 1 is equal to 0, which means that x is equal to, when you set both those equal to 0, 4/3 and negative 1/2. All right, there you go. All right, first page done, and my hand is hurting. All right, let me see how that looks. Looks good, and we're going to save real quick, and then let's move on to the second page. All right, so second page, for each set of solutions, write a quadratic equation in standard form. So these are really cool questions because they're backwards. You have to do all the stuff you were just doing except work it backwards, okay? So let's go ahead and do that. So if x is equal to 5, before we did that, we set it equal to 0, right? So that must have been x, that must have been x minus 5 is equal to 0. And this must have been x plus 8 is equal to 0. And working backwards again, that means that it must have been x minus 5, the factor x minus 5 times x plus 8 is equal to 0. And then just simply multiplying these out, double distributing, you should end up with, it looks like x squared plus 3x minus 40 is equal to 0 by multiplying these out. I know I'm skipping the whole FOIL or double distribute, but some of these are pretty simple, so you can do some of them in your head. Sometimes they're not that simple, but this one was. Anyway, all right, so this next one, this one's a little bit interesting. You could just subtract 7/5 and add 1/2. But I'm actually going to show you probably a better way to do this. I'm going to do this in 2 steps. I'm going to first multiply the 5 over, right? I would multiply both sides by 5 to get it over from here to there. So that would be 5x is equal to 7. And I'm going to multiply by 2. So that would be 2x is equal to -1. And then I'm going to go ahead and subtract the 7 over. So this is 5x minus 7 is equal to 0. And this is 2x plus 1 is equal to 0. And that means that I must have had 5x minus 7 times 2x plus 1 is equal to 0. Those were my factors. And now I am going to actually multiply this whole thing out just because there's numbers other than 1 in front of these x's. So anyway, so that would be 10x squared. And we'll multiply the front here, which would be plus 5x. And then the back, which would be minus 14x. And then minus 7 is equal to 0. And then combine like terms, so it's just 10x squared minus 9x minus 7 is equal to 0. And there you go. There's your equation in standard form. These are kind of fun. It really tests your like how fluent you are in solving these, because you have to do it all backwards. So anyway, all right, let's go to the next problem here. So we have the manager of Fence Me In is trying to determine the best selling price for a particular type of gate latch. The function P of S is equal to -4s squared plus 40s minus 8400. Models the yearly profit the company will make from the latches when the selling price is S dollars. Okay, so write a quadratic equation that can be used to determine the selling price, which is S, that would result in a yearly profit of 1,600. Remember, this gives you the yearly profit. So in this case, P of S will be 1,600. All right, so in this case, we have 1,600 is equal to -4s squared plus 400s minus 8,400. Okay, and so in order to put this into standard form, I just have to set this thing equal to 0, right? And that's the next problem here. So I'm going to subtract 1,600. That's it. So here I have 0 is equal to, and usually we put 0 on the other side. So I am going to actually kind of move it to the other side just because you're used to seeing it that way. But you know, you normally have this. Actually, you know what I'm going to do? Let's flip-flop all these, because actually they want the coefficient. I didn't read this. They want the coefficient of 1. So actually I'm going to add everything over to this side to get the 0 on the right. All right, so that would be 4s squared minus 400s. And then when I add 8,400 over, that should be 10,000. So plus 10,000. 1,600 plus 8,400, yes, that is 10,000, is equal to 0. All right. Now they also want the coefficient of 1, and right now it's 4. And notice all of these are divisible by 4. How lucky are we? So we're going to divide everything by 4, and we have s squared minus 100. And 10,000 divided by 4 should be 2,500. So plus, oops, don't forget about my s. That's better. Plus 2,500 is equal to 0. And now they want us to solve the quadratic equation by factoring and interpret our solution. So let's just go ahead and do that. So I want two numbers that are going to multiply to get to 2,500 and add to get to -1,000. So that should be -500 and -500. Okay. Yeah, that should work out. And let's just put in our x just so you guys know that that's what we're doing. So I have 2,500, and that's multiplication. And here I've got -1,000, and that's addition, and that should be negative 500 and negative 500, which means that we have x minus 500 times x minus 500 is equal to 0, which means that x is equal to 500. There you go. All right, how could we check our answer to part C? Yeah, well, let's just plug it in, right? Plug it into A and plug it in for S and see if you get 1600. So we'll say plug 500 in, that is, in for S in part A to get, what were we getting, 1600. There you go. All right, last problem here. This should be fence me in, not fence my in. Fence me in has been asked to install a fence around a cabin. Here we've got our cabin. So right here, this shaded area should be our cabin. Okay. Anyway, the cabin has a length of 10 yards, which they're showing right here. So you see this 10 yards. That means this is 10 yards. And a width of 8 yards, and same thing right there. All right, there will be a space, and I believe this is supposed to be an X. Must have just messed up when we copied over. A space X yards wide between the cabin and the fence on all sides. So we've got the cabin, and then we've got these X's here. So you can see this is X wide, and they've put the X's on the outside. Okay, and that's fine. Let's see here. The area enclosed by the fence. So this is the whole fence, this outer rectangle. The area of that should be 224 yards or square yards. Okay. All right. So let's go ahead and answer these questions. Write a quadratic equation that can be used to determine the value of x. Okay. Well, first of all, we know that area is equal to length times width, or length times height, whatever you want to call that. And in this case, our area is 224. And our length, in this case, the whole length should be, this whole length is going to be 10 yards plus x plus another x. So we'll say 10 plus 2x. And actually, I'm going to flip-flop this around. I'm actually going to say this is 2x plus 10. And that's just a little foreshadowing, because I know I'm going to have to multiply these out, and I want my x squared to appear in the front. So that's really all it is. Anyway, and then so we also have on the side here our height, which is going to be 2x. 2x is plus 8. All right, so let's go ahead and fill those in. So our length was 2x plus 10 times 2x plus 8. I mean, technically that suffices. That is a quadratic equation, but I'm going to write this in standard form. So let's go ahead and multiply this out. So this is 224 is equal to, and that will be 4x squared. What is that? 20 plus 36x plus 80. All right. And these are all divisible by 4, but I'm actually going to move this over first. So this becomes 0 is equal to 4x squared plus 36x. And then subtracting, let's see here, we have minus, so that's 144, minus 144. So 80 minus 224 is 144. All right, and then just dividing everything by 4 now. That is going to be, I'm going to move this 0 over to the other side. So that would be x squared plus 9x. And I think that's 36. Let me just verify. 144 divided by 4 is 36. Yeah. So x squared plus 9x minus 36 is equal to 0. And there we go. Okay. By the way, you could like these bigger numbers, if you graph this, it will give you the exact same graph. Like, there's nothing saying you can't just like multiply these by both sides by massive amounts of numbers. You're still going to get the same thing. So anyway, all right, so solve the equation by factoring. All right, now you guys might be thinking, well, wait a second, didn't we have factors up here? And the answer to that question is no, we did not have factors because it has to be equal to 0. So in order to get this 224 inside of this equation, you actually have to multiply it out and then subtract it over, as we did. And then we have to refactor it. Okay, so let's go ahead and do that. And in this case, the factoring looks like it's pretty easy. So I've got, I guess we won't be lazy. We'll write this in. So negative 36 for multiplication and positive 9 for addition. And that looks like it's going to be 12 times 3. So that would be 12 and negative 3. All right, which means that since our coefficient in front of the x squared is 1, we can go straight to x plus 12 times x minus 3 is equal to 0. And we're going to go ahead and solve. So setting both these equal to 0 would be x is equal to negative 12 and x is equal to positive 3. So this one is good, and this one is no good. And the reason why, so we're going to say x is equal to 3 because, actually let me make this a little bit better. X is equal to 3 because you can't have a negative length. And by the way, you're going to see a lot of that in solving quadratic equations with real life scenarios. Typically one will end up being negative, which you won't be able to use, but you will be able to use the other one, which works out really nicely. And if we want to interpret, we'll say the length in this case is now going to be equal to 10 plus 3, which is 16 yards. And the height is going to be 8 plus 3, or 14 yards. Okay, and so let's go ahead and put a box around that for our final answer. Okay, that should take care of all of the practice questions for our off the script lesson for 7.2 and 7.3.